So yes, I think there is a little bit a contrast.
Or maybe we should really need both, because I can see the needs from both sides. I mean, this is like being able to use a tool like JMT. It's like so appealing for teaching, for students. It's like the understanding. This really can appeal because it offers the immediate gratification, right? And at the same time, understanding the whatever is behind it, I think it's also valuable. So I would say that it's not contradictory, but just sees another point of view that when we can really make it more attractive to students.
Yes.
I think that brings really back to the point of the amount of time that you can devote to this type of topics, because it's really like the chicken and the egg. On one side, you want to do first the basics in order to be able to do the application in the right manner. The other, probably taking the Giuseppe's approach, you are instead attracting people, students, because the application is really more attractive, because the animation is attractive. But then later on, I think that personally, I think that you should not really content yourself with this. Then you should really develop the theory that is behind. I still think that university should really focus more on basics. I still have this idea of university, which is probably old-fashioned, and but I agree with Giuseppe that in order to have students which are really attending our classes, then probably you have to be more use more inflation techniques. I don't know. That is what when I was saying before, that I would like to collaborate with some young so that we can put together something which is more attractive and still which is valid, because I really believe that it is true that what Giuseppe was saying, that none of our students will really spend too much time in building their own simulator or their own computational algorithm for the solution of QA networks, their own AMVA or things like that. True, completely agree with that. But I also think that if you're really making your hands dirty in order to play with the random number generator first, then play with the generation of instances of random variables, play with the way in which you are really building the core of the simulator, so that you understand there can be many ways of doing simulation, even discrete event simulation, and which are some of them which are more general, which allow you to easily integrate any kind of model, and other which instead are more limited. And I think that those things, once you manage those things, then you will be able to manage also more realistic or important application. But I agree with Giuseppe that by focusing on the theory, which is really not theory, but in any case, on this more theoretical background, then you are not attracting people, and that is for sure. That is my experience.
I wonder if some of this could be mitigated by setting up labs with dummy systems that one could actually measure and through which one could actually drive load. Because then you would be able to make a straight connection between something hands-on that's happening in a controlled environment and stuff that you're trying to predict. So for instance, if you want to model priority queuing behavior, you can look at the effect of different scheduling algorithms in an environment and also understand the limits of the data that you can capture and the limits of what you can actually model and the extent to which you have to approximate.
I agree with you that labs will be very important, but again, it goes to the amount of time that you can devote to this. So the first big competition, if you want, with colleagues in the building up of the programs is how much time we think, but can we devote to this type of topics? Because if we have the time for doing what you were saying, I have the more theoretical thing, then I have a lab where a lot of these things are really already organized so that I can do measurement, I can really show easily how by managing on things, by changing something that you get completely different result. Still, I think that I really still think that having the student getting their hand dirty by really building the core of a simulator is an important important experience.
I agree with you. The question in my mind is how we can get them to use the
Yeah.
simulator to actually learn something.
Yeah.
And one could relate it to their one could relate that to their daily lives as well. For instance, I can't tell you how many performance conferences I've attended at which there's a huge queue for the food because it's a single pipeline at the buffet.
Yes, of course.
And this is something to which the students can relate.
But also the gas station is really very easy. I mean, if you take a gas station and you can do a lot of things on the gas station, which are really which allow you to really get into details, a lot of details about priorities, about reorganizing the way in which you are really having the car get into the different pubs.
Or speed mismatching with toll collection on a motorway.
Oh yeah, the same.
So this ties directly to what Moore was talking about this morning with the load splitting between the short jobs and the long jobs.
Yeah.
On the Garden State Parkway, we have separate lanes for electronic toll collection and cash.
Yeah. No, but I agree with you. And in fact, I think that having a lab probably would be really a good idea. The problem in my case is that I just cannot have the allocation of that time in
No,
my
it has to be integrated with the other courses, I think.
Yeah.
And that means bringing one's colleagues on board as well to get them used to the idea that they want to be instrumenting for the sake of performance because it's an integral part. And that comes back to the basic performance engineering question. Should you tie requirements in with modeling, for instance? I believe one should.
Giuseppe?
What I want to say is that we should integrate anyway the course with some presentation of models that are attracting also. For example, we have 1 hour, we can present to students a model that can discriminate between falling rocks from the rock mountains and earthquake, or a survey the sizing of a surveillance system in an airport with all the video cams and all the throughput and all the response times that happens. This is not very hard, very different from the example that Moore has shown before with such a very high coefficient of variation, because flow passenger arrive, then from 2 hours no more passenger or some other, or a system that automatically detect the fluctuations that works maybe better than with respect to Amazon or Azure. We can explain the models. The models are already implemented, but with the simulator can be executed. But they see how they touch with this problem, the real world problem. And this is important to attract students, according to me.
I totally agree with Giuseppe. So I think collaborating with your peer colleagues might be one approach. Another viable approach is use your graduate students. You see, I rely on my PAs and my graduate students heavily. I in fact ask my TA to design the project for me, and it's often through my TA. They find what's interesting, and then they design the project, and then they make the student interested. And that's also another way to bring the students, kind of get them connected with the real world. For example, we have students do like projects on gas station, or maybe DMV office, and could be simply cafe and Amazon online service, and then COVID vaccine center, etc. So a lot of this idea from the my teaching assistants, and they actually have the passion unfortunately, I was fortunate enough to have a few very good TAs kind of and they need to have like the well training in performance modeling. They need to understand both the basics and the theory and the application. Yeah. Otherwise, it's impossible to do it completely like by myself.
It's another contradiction that between what Giuseppe said and what others were saying. So Giuseppe was saying that we should cut down on the mathematical content, whereas before that the discussion was no, we should train the undergrads early so
So
they
I
can
don't
understand.
think it's such a contradiction. So I think that maybe the answer is we should really have both. They're two very different courses. I mean, there can be a course in mathematical training, and that's great, but there can be a completely separate course, which is Seppi's saying, is you can have a course that's just called applied performance engineering, or or whatever you want to call it, that indicates that it's very, very applied. And maybe that course just moves between different applications, like maybe 2 weeks on where performance comes up in networks, 2 weeks on performance in operating systems, 2 weeks on performance in the cloud, whatever topics you want to move through, 2 weeks of performance applied to edge computing or serverless computing or whatever your hot topic of the day is. And that makes actually good sense as a course. It's just a different course. But it sounds like a fun course.
Industrial control systems too, like conveyor belts.
Sure. And maybe the course even rotates in terms of the topics that it covers. So maybe one semester you pick topics that are related to cloud computing or something, and then a different semester you pick topics that are more related to manufacturing or something, or I mean, you can move through different topics, but in each case, like you switch every week or two, every couple of weeks you switch the application a little bit, staying within the same general area, and always ask, how does performance relate to this?
Could even pick
That's
something
one way
topical.
to do it.
That would be.
That's one way to do it. You have a course where you like 2 weeks on cloud and 2 weeks on blockchain or whatever. But would an alternative work where you get yourself invited to a OS course or the networking course where you go in and give a guest lecture that introduce them to some
So
technique? I've
done that, and I don't think that works nearly as well. So one lecture is not enough to teach people performance. It is, I like Giuseppe's idea a lot better. You have the whole course is about performance, and you just maybe move through. I would move through pretty quickly different application areas.
Or are you going to try and attract students from different domains so you could get the civil engineers in as well, for example, to share their experience with the computer science types?
That would be interesting. I don't know. I mean, right now I have students in my class who are computer science and engineering and OR. Actually, the OR people, it's a requirement for them to take the course, and OM, and math. I haven't tried civil engineering, but it's definitely a possibility.
See, your students are a mixed bunch, right? They're like engineers as well as computer science people.
Me, from my
Guilty.
PhD class, it's a mixed bunch. For the undergrad class, it's only computer scientists.
Evgenia, maybe you want to say something? I see you.
Seems to me,
to...
yeah, it seems to me like these are like fantastic ideas, but I think what really to fill in the gap, I think clearly we don't have enough education. We don't. I mean, whatever we have, because whatever the people who go then out there, they work in industry, they're missing fundamentals. I think this is clear. So at the same time, we need the theory and we need the applications. Maybe what we really need is more classes, more different classes that, the same way that there is not a single machine learning course, right? There are several, the same thing we need. So
Yeah.
so we can have like the appeal of applications is tremendous. But how to do the applications if we don't understand the fundamentals?
This is the problem.
Yeah, so one cannot go without the other. I think maybe that's the way that we should be thinking. But maybe what we really need is for our flagship conference, like Sigmetrics, right? Sigmetrics Performance. They are the conferences of our field, right? Don't you think that it is necessary to have like this kind of conversation, this kind of workshop, perhaps like every single year, and perhaps like look at it from a different point of view and expose these things to a broader community? Because I find this discussion very stimulating and very interesting, very useful for me as a teacher.
Yeah, that's an excellent idea to have this every year. I like the idea of every year discussing how we're teaching things, and maybe that will help us develop other courses.
Like this, we're brainstorming here, right? Because we all face the same problem and we're like, okay, how can we solve it, right? I think we need this thing more.
Just as information for you, Bondi, maybe over the years, the most enthusiasm and positive comments on the help that we did to forum was by two people. One is manufacturing, because he's working on FMS or something like that. Really, this guy, I don't know who he is, but say, oh, you changed my world, it's fundamental for me, etc. And the second one was from a physician that has two sides and AR beds in a hospital ward. He has a terrible problem in London. That was, frankly, I don't know how he finished, but this guy also appreciates a lot the possibility to implement fast simulation or something like that. The other one, computer science people, students, yes, they ask several times. They ask just to do homework or something like that. That is my feeling. But this helped. Another one that helped, reminds me, was to model how many cashier has to put in a mall to minimize the number of etc. of time that people is there to pay or something like that. But that's it.
It's in Pritzker's textbook from the 1980s, Introduction to Simulation and SLAM, by the way. They occur there too. I ran into an interesting one. There was a supermarket in California when I was teaching there a long time ago. They had a policy that if there were more than 3 people at any cash register, they'd open up another cash register.
Wow, this guy now.
So I set that as a simulation example for my students, actually. But then I called the supermarket manager and I said, how do you decide when to send people back? When to close the cash register down because there aren't enough people there anymore? Send them back to stocking shelves. He couldn't relate to the question.
Of
course, that was very low level, but I wanted to have something the students could seize on.
I'm busy. Please give me 5 minutes.
Yeah, that's an excellent question, and you do have to shut them down too. So this is the same thing that comes up in power management. And power management, if the response times aren't good, they turn on more servers, but they don't want to keep the servers on forever because they're using a lot of power, a lot of energy. So you do need to shut the servers back down or put them into some kind of sleep state or something. Otherwise, you're just going to be wasting energy. So it's a very real problem.
Very hot.
Believe me or not, I think this message, our education are not wasted. Eventually, actually, you go through. For example, we do talk about like how do you modeling like a shopping mall, or maybe like we do a Kroger, and we actually once they understand like the demand, or maybe that it's non-stationary, then they need to have a schedule of staffing, and a lot of time these graduates, once they exit, and then they will become real system managers. I think it's going to go through yeah.
There are a lot of hot topics today that we can solve with easy model. The surveillance system, safety system, video cam, and all these systems can be done by open system MM1 or something, if you want multi-class. Okay, I agree. but also the multi-class concept is very important. So the one that more in the example she explained at the beginning is fundamental for the performance. And so we can apply that to some interesting, very trendy models like airport surveillance, city in the town, very smart city, for example. All this is called, if you want, data lake. Now with the data lakes, with the data that move, they have different types, etc. They have interesting problems that are just emerging now. And with simple models, QNLs, and if we use this keyword in the program, we may reattract students to our courses. But I agree with all of you that you have told, we can't do that in 50 hours course. That's the major problem. At least 2 courses minimum. The one maybe to undergrad, and the second one maybe for grad students. This can be. I'm not talking about PhD. This is completely different education. But undergrad also, they have to take statistics. They have to take probability. So we have to go into the course of probability or statistics and give 1 hour, 2 hours lesson how this concept of statistical probability can be applied to forecast performance. We may ask.
Sorry.
Sorry.
Giuseppe. I see we have other colleagues from different university. I would be very happy if they would tell us their opinion, their experience, if it's possible.
And a proposal. So I've been teaching performance evaluation for quite some time now. And as many of you have said it already, we faced a lot of resistance. Resistance from students. Why should I do this? Why am I not coding? What is this strange equation? What is MM1, right? I don't see the point. Resistance from colleagues, like a lot of people in charge of curriculum development are people with systems background, compilers, programming languages, whatnot. They don't see the value. Why should a performance evaluation or performance engineering course be part of the undergraduate curriculum? They don't see that point. And of course, industry, I think we have heard that repeatedly. They like practical performance analysis, but Little's law or MM1 or mean value analysis, it's just too mathematical. We don't see the point, right? So we keep encountering these resistance, but we're all convinced that performance analysis is important. The cost of not looking at performance early enough can be catastrophic. So we are kind of, it's like preaching to the converted, right? Preaching to the choir. So I wonder whether we as a group should kind of address these questions which come up repeatedly, maybe write a position paper or something like that, maybe come up with some examples, like a TLDR version of why performance analysis is crucial and important. For example, I talk about healthcare.gov, right? The website failure. I talk about pandemic response websites not responding in time, the very real impacts of bad performance. But instead of saying that repeatedly, I wonder whether we should pool our collective expertise and maybe write some stories or case studies to kind of put this to rest, that, this is not something which has to be debated. Teaching performance analysis for software developers, engineers is very, very crucial. And here are some real life examples of how, for example, Little's law could be used to validate a performance test, or how you could use bounds analysis to kind of quickly figure out if two designs are which of the two designs to kind of proceed with, right? So I wonder what the opinion of the group is. Should we do something positive so that we don't get the same questions again?
I think one of the things we need to do is try and get more cooperation from industry. One of our problems is that the performance of systems is something that's commercially sensitive. It's something that companies don't want to talk about because it helps to define their competitive edge. And On the other hand, we need those examples to educate others in industry, but also to motivate students that there's actually going to be some applicability in real life. Sometimes in industry, I've seen absurdities like people panicking because the CPU busy is 100%. Well, it's a batch type job, and that actually indicates that work is being done. So if the utilization were 0, there'd be more cause for panic, I think, and things of that nature as well. So if we could find a way to get real examples from industry suitably camouflaged that we could show the students, that would be helpful. The other thing that we might want to consider doing is talking to the companies that actually do measurements. And there are a lot more of them now than there used to be. There's so much more, there's more instrumentation than I could have dreamed about when I was starting out. And that's fertile ground for fitting models and motivating models and so on, including understanding why response times fluctuate and why response time is a large response time with a large throughput is indicative of a need for large number of memory, large amount of memory or large number of discrete objects and things like that.
No, absolutely. I think the mathematics is just too scary for students and industry. So I think really having nice, like you said, and realistic case studies, camouflaging real life situations and showing how you could apply something as simple as Little's law or MM1 to analyze and possibly preempt some of these problems. And maybe, it could be like a magazine style article, which can kind of evolve, like we kind of update that every 2 years with modern examples, maybe, which you can quickly point out to people, students, for example, or decision makers, to show why teaching some of these analysis concepts and performance analysis and modeling is so crucial. You're building the next generation of people who don't do the things which Shimor mentioned about, right? Don't know what Poisson is, or kind of have the deterministic thinking. Don't know what variability is, right? Do one experiment and report that in thesis. The number of times I see student theses where somebody just does one experiment and says, here is the average. Believe me, my stuff is better than the existing work. It's mind-boggling, right?
We do that. I've seen that in industry as well, but we have the advantage of being able to do experiments in a very tightly controlled environment sometimes. So the need for randomization is reduced, and the setup cost of doing experiments is actually very high, especially in systems with a large backend database where you have to have a lot of anonymized data and roll back the database to the way it was before the experiments that you can replicate. It gets extremely expensive.
So given the ignorance in the industry, I think we should reach out. But I'm not would writing an article that is refreshed every 2 years be the right way to go about it? Would it work for Sigmetrics or IFIP to start some wiki pages that the industry people can refer to?
The question, that would be great, but are they gonna go there and do it? Somehow, you got to put this thing really to their face to see it. So maybe a consistent presence of education like this, and I think it's not just the industry who needs this thing, but in general systems people. If I'm gonna make like a comment about the current status of Sigmetrics reviewing that I'm doing. So I end up recently getting like a lot of systems papers. And a lot of times the way that people describe their experimentation, it seems to me that they're missing fundamentals. I mean, they're really missing fundamentals. And these are people who are submitting papers to Sigmetrics, right? Which, I don't know what's your experience, what kind of papers you have been reviewing recently, but it seems to me that the quality of, experiment design and how we do things, it has dropped the recent years. Maybe I sound like really like an old person. Past used to be great, not anymore. But it is a problem. I'm like, and you got to put somehow these things to the faces of the people. So how can we do this?
There's also a misconception out there that because the cloud is infinite, we don't have to worry about performance anymore. And that's not true, because the cloud costs money, just the way mainframes did 40, 50 years ago.
So what about the idea of giving tutorials at systems conferences? So Evgenia, you said you need to be in front of people and you need to tell it to them to their face. So suppose we went to systems conferences. I know I've given talks at like ISCA, ICDCS. I'm talking about like tutorial talks or, you know, keynote talks or something of that kind of sort. But so maybe it's tutorials that are the way to go, and maybe it needs to be done consistently. Maybe every year, every systems conference needs a tutorial on performance, just on what performance is about. And then, you know, they can go back and learn more. But this would be a little bit more in line with what Giuseppe was talking about, where we would basically be talking to them about the applications of performance. Here's how performance applies to you. Here's all the great things you could know if you knew a little bit more queuing theory. You know, stuff you could do if you knew more queuing. And maybe that would motivate them to learn it.
Could you elaborate on your experience giving these tutorials at these conferences? For example, how many people showed up? What kind of questions
Yeah,
did they
so
ask?
I remember I gave an ISCA tutorial and it was 3 hours. And I tried to make things really funny, like I have prizes and all sorts of different toys that come and, you know, to illustrate various points. I think I had about 30 people at the tutorial. I would rather have had a lot more, but the first half I had 30, and then I guess there was a break, and so maybe word of mouth spread. So the second half I had 40, maybe 45, not much more, but you know, some extra people showed up, you know, for the second half. My feeling was I wasn't able to go into any math. Anytime I brought up a distribution or anything like that, it became too hard. It was much better if I talked in a very applied way.
But
You know,
sorry, this
basic lessons
comes back to the problem of education.
It's
Since
true, but
these people comes from.
But years later, people told me that they remembered the tutorial and they now remember the importance, and it did encourage them to go back and look at more papers. It definitely got people citing more papers, you know, more performance papers. So it educated them a little bit.
Do you think your industrial clients would be interested in more training so that they don't encounter the kind of performance pitfalls you were brought in to remedy? Or is labor turnover so high in the industry now that that's simply not sensible?
So I've thought about it. I wish I could answer it for you. So my sense is companies seem to be very happy to pay a lot of money to somebody to come in as a consultant. They call it a visiting scientist or something, you know, to help them on their particular problem. And so you would think maybe they'd be happy to like train people to learn more in terms of classes, but I'm not sure that's the case. Like they like it when it's very targeted to their particular problem.
Mm-hmm.
And one of the things that I find I have to do is to just basically listen a lot. Like I just listen and listen and listen to try to understand their exact problem. And then I can give them a solution that's tailored to them.
Right.
You know, like maybe they don't want their jobs preempted. You know, maybe there's a big cost to switching between different types of jobs, or I don't know what. I have to listen to all these details and then come up with a custom-made solution. Yeah, of course, I would rather we do more teaching, like teaching of industry, you know, in terms of executive education. I would rather we do more of that. And maybe that's another way to do it. Maybe we can start, maybe Sigmetrics can start some kind of executive education course. And maybe companies would pay to have their employees come and do this executive education. I know, who is it? Raj Jain does this or something?
Raj Jain, also the practical performance analyst.
Right.
Neil Gunther.
That's it. Right. So
he does a lot of that very successfully.
They do executive education, and maybe there should be more executive education done by people like us. I would not mind doing something like that in a group, you know.
What would be the course content, roughly?
So again, I think I'm agreeing with everybody here. that it makes sense to have two different types of courses entirely. There could be the theory of performance modeling, but then also what Giuseppe said, which is the practical applications of performance modeling, practical performance evaluation or applied performance evaluation. I don't remember what the title was exactly. And maybe people sign up for one or they sign up for the other, and maybe they're encouraged to take the other one afterwards.
I believe this may be a good idea if to have this tutorial online, so people from industry, they don't have to travel, but they can take the course directly from their location where they are following this tutorial. In this case, you may increase a lot it became something like a MOOCs course on performance, basic or the other, but also the cost can be limited, and people can register to tutorial without registering to the conference, maybe, because this is another possibility. The other possibility is to have a MOOCs, MOOCs, very focused on these topics, and then try to distribute the MOOCs in some occasions, I don't know, different Sigmatrix and other conferences.
I found if they have recurring targeted problems, it's actually useful to go to the customer's site and just have a course specifically for one company, because then they feel free, they feel more free to talk about proprietary problems.
It's
so
true.
There's a market both ways.
Yep.
The kind of thing that I just described is really only suitable for large companies or mid-sized companies where they have recurring problems and a large capital base. They can afford to have their people spend time on this kind of thing.
I think in terms of how to influence the industry, I mean, through education, we can definitely, have an impact. But another way is maybe publication. For example, it may be through your consulting experience. If you publish your success story, maybe instead of publishing at just like some traditional, very technical conferences, if, for example, if you share some success story at, say, Harvard Business Review, if you will let industry kind of clearly see that how through the help of performance modeling, and then can really make an impact. I mean, that can probably also influence industry. Because recently, in one of my seminar I was given at a university, I was talking about Amazon, like, how Amazon is using massive scale parallel processing, how they're achieving, short delay and then, fast delivery and a maximum throughput. And so this kind of example, like if it can be really kind of be showcased with the combination of performance engineering, I think that will probably allure some industry to look into it. In fact, it's very interesting how Amazon avoid, like, they're sending you a single item. If you order two, and then they're going to send you two single packages, really to kind of achieve this 0-day or 1-day delay. And then a lot of these are performance questions. So I guess similarly would be like in computing system, maybe like, how your intelligence has made the system performance improved drastically, and then that can be maybe, influence. But then definitely we need to go out of our comfort zone, right? Maybe more visible papers like in the business world.
How about the problem of catching them young, right? Training people with performance skills when they graduate. Because if you look at the draft curriculum for, I think, software engineering proposed by IEEE, there is no mention of performance analysis being an important skill. And my colleagues have often abused that. So whenever I propose something, they say, hey, look at the ACM draft curriculum, look at the IEEE draft curriculum. Nowhere does it mention that performance engineering should be a required course. So this is something which is like a, MSc or PhD level. Our students don't really need it, which I obviously don't agree with that. So should we as a group do something to kind of influence thinking, at least do rigorous study or something like that to maybe modify these curriculums, which are quite frankly old. I mean, they've not been updated for 10 to 15 years, but they're still being used or abused to shut out certain important skills from students. I absolutely
Excellent
think that
point.
doing like black box analysis, looking at just doing mere coding is not enough. You just have to analyze the system. Look at performance issues. That's absolutely essential if you want to call yourself an engineer, software engineer. But the thinking is not that, unfortunately.
Is there government research funding in performance so that PhD students will be motivated as well? Professors can support them. What is the attitude of funding agencies towards performance research and performance teaching right now?
Performance teaching, I don't think so. Performance research, unless it's kind of couched in very attractive hype, like the flavor of the day research,
Right.
it's a tough sell.
I was afraid you'd say that.
Yeah, but in general, I think I absolutely believe that you should catch them young. They should graduate with good performance skills. But it's a hard sell, even within the university, for example, to say, okay, there's limited real estate, there's limited number of courses we can teach. It's very difficult to convince people that performance engineering should be like, we only have 44 courses we can teach. Performance engineering should be one of that.
So, DeWalker, can you say a little bit more about that? So you're saying that the people at your university are looking to some kind of guidelines to determine what courses they should or shouldn't teach. What are the guidelines exactly?
So, we do this curriculum exercise, right? And it's always a question of like managing student workload, getting in what the committee thinks somebody should graduate with, like the graduate attributes and things like that. So there's always like a push to modernization, like teaching really modern stuff like cloud computing, right? Between that and more fundamental topics. But what happens is that there's a lot of focus on things like requirements, functional testing, software design, UML, those kinds of topics, but very little on performance testing, for example, right? So you find that typical software engineering undergrad curriculum, at least in Canada, a lot of emphasis on uncovering bugs, but nothing about concurrency. So what happens when you have like thousands of users? You might have totally new types of bugs and new types of performance problems which won't be exposed when you do functional testing, right? So there's really lack of emphasis. And when we try to propose courses to fill those gaps, the argument is, look, we can't do everything. So certain courses are more apt for specialization after somebody graduates. And as evidence, here is this draft IEEE curriculum on software engineering. Here is this draft ACM curriculum on undergrad software engineering. None of those two, both of these two don't mention performance engineering as
I
a
see. So you're
graduate
saying
attribute.
we should create our own draft
Mm-hmm.
of what a curriculum would look like or why it's important so that like universities have something to cite. Is that what you're getting at?
Yeah, exactly. I mean, the performance community's voice in some of these curriculum discussions is missing.
That's really, really important. I mean, if we don't have people teaching the courses, how in the world are people supposed to learn this? And then Evgenia is going to say nobody knows anything, but it's because
Yeah,
there weren't
exactly.
any
I mean,
courses.
for whatever reason, some of these the people who do this work, the curriculum work and standardization work, there seems to be very little representation from performance engineers,
I see.
And that's hurting us, I think.
Right. And maybe it's also hurting that there's less funding for fundamental queuing kind of research. By the way, I get funding for queuing type of research from CMMI, in case anybody's interested, NSF CMMI, but okay, even there you have to attach it to an application.
Mm.
We have another 5 minutes. Anyone wants to raise a new point?
maybe one thing we can do as a group is like, I mean, we all have like years of teaching experience, and then we all realizing, you know, I think students are liking the fundamentals. Maybe we can come together, say, for undergrad students, you know, what are the core elements, you know, that's suggested to be, because, and then for graduate students, what are the core elements we think are important? And then maybe this can serve also as guidelines for maybe future teachers.
I think one of our problems is that students see courses as being self-contained rather than feeding into each other, and they don't necessarily learn how to integrate what they've learned in the individual courses and try and leverage that. I remember when I was young and naive, I taught a performance course, and they said Dr. Bondi is crazy. He talked about the Laplace transforms and page virtual memory and linear algebra in the same hour. And semaphores.
I think it would be necessary to continue these discussions with other colleagues. So we can think to have a second workshop, or
It would
At
be
least
nice.
within among us, I guess I'm hearing that you think there should be some follow-up. I mean, Victoria and I bravely call this the first international workshop teaching performance analysis of computer systems. You know, if you call it the first workshop, you expect to have a second workshop. What do you guys think?
I think it's a great idea to have a second one. And I would think that Sigmetrics performance is the right venue for this kind of thing.
Also, we had WEPI at ICPE, for which Vittoria was one of the early chairs. We're actually having that only every other year, but it's not too late to put together a workshop for our April conference, probably, if someone wants to do that.
So, Eugenia, you are familiar with ICP. Do the two workshops match, or are they like different in nature?
I think you're going to have a lot more visibility doing this thing in Sigmetrics like that, rather than at ICP, which is a small community, a small and more, and it's not. I mean, it does not have the visibility of Sigmetrics.
True.
And Sigmetrics is, you know, it's for performance. For performance evaluation, that's the flagship conference. So if you want to have this thing like on the face of people, it's got to happen in Sigmetrics. Even though there is some repetition with WEPE, okay, it's all right. What's wrong with that?
Different audience.
Yeah.
Yes, also different aim. They usually, the aim is manning the gap with industry. We are talking about teaching that has different problems, is a different point of observation teaching. So I think they are both, of course, both valid, but at different point of view.
Plus, having this kind of thing, even in places where it's good to give more visibility to the issue, to the problem. So, I mean, like, could we have, for example, in Sigmetrics, every year one tutorial, perhaps like on, that would be also great. Maybe just a workshop like this one would meet the needs. But there are needs. I think there are clear needs. That's what we're all discussing here.
Would the people who need it be at the conference?
Well,
like, no, the systems people, would they come for this workshop?
So the plan
Or
is
the
to
industry people, would they come to this workshop if
No,
it's at
no,
Sigmetrics?
they won't be there, but the workshop is about trying to figure out how to create the curriculum or create the position paper that Diwakar was talking about, or create the executive education course or MOOC or whatever other people have mentioned. Okay, that's the point of the workshop. And then once we have a plan in mind, then we have to go give the tutorials at the systems conferences, or I don't know what, present the paper to NSF or whatever it is we come up with.
Absolutely. Yeah.
Just need more visibility. I think
Yeah.
that's necessary.
And visibility for various target audiences, right? For industry, for students, for curriculum designers, for standards bodies. So it takes a lot of effort, and I think the workshop recurring every year would be really useful.
Okay, so the discussion was supposed to be now what to do, right? So I'm the list of things that we've discussed, come out with the curriculum, think about formulating tutorials for the system conferences, case studies, targeted at, let's say, Harvard Business Review, the position paper about the position of performance modeling analysis, executive education, and then some more stuff that were in the presentations themselves, like the use of digital tech, how to leverage on the toys that our students are familiar with, Kahoot and everything. The role of simulation and all that. So all this is a lot of material to work through, and it deserves another workshop. And we propose that the next Sigmatrix performance, the one in India is going to be a joint conference, right? So we should propose to have a workshop there that talks about teaching performance analysis. So is that a good wrap up of what we've been doing? Anything else to add?
It just occurred to me that when I was a student many years ago at Stanford, actually the department runs something called industrial workshop. I served as assistant in that industrial workshop. So actually every 1 or 2 years, the department would organize an industrial workshop, inviting all like executives to join that. It's like a few days of workshop, but then they're going to educate them, the importance of all this. I mean, using success stories. I think, this could be something like maybe a bunch of performance engineers collectively can kind of deliver.
But Stanford being Stanford, they can like get people to show up. If you are some other university, it might be a bit harder.
That's true.
So I guess it's time for me to wrap up.